Hi students, welcome to today's class. Today I am going to explain definite integration of periodic functions. Okay, yesterday's class I have explained definite integration of greatest integer function. Now I am going to explain periodic functions. Whatever may be the function we have taken here, integrand, all are periodic. Already we completed what is a periodic function. The periods of various trigonometric functions are also we have seen. Okay, the properties of periodic functions are also we have seen in the chapter sets, relations and functions. Now I am going to explain if it is a periodic function, then what is the, how to find out is the integration. Okay, right. If it is 0 to nt f of x dx, where here n is a natural number, t is the period of this function, whatever may be that, t is the period of function. This is given by the formula n times 0 to f of x dx. That means 0 to t, whatever may be this natural number will come as a coefficient. Then what is the explanation, what is the proof of this theorems are very easy, very easy. I am giving a explanation. So let us take that x-axis and y-axis origin. Here f of x is a periodic function of the period t. Periodic function of the period t. That means, so this is, let us see the graph of this 0 to t. Since the interval, length of the interval is t, again t to 2t is also same shape, 2t. Again 2t to 3t, 3t, 3t to 4t, so on nt. So n minus 1 to t. So there are so many n minus 1 to t. That means what? Integral 0 to nt f of x dx means what? Area of these regions. Understand this? Area of these regions. All these are regions are there. Area of these regions. Area of the regions. What is the area of the region? So all are periodic only, no? So here how many such type of figures are there? There are n figures are there. 0 to t, 1t, 2t, 3t, 4t, so on, nt. There are n t's are there. So can I write down n into area of 0 to t, whatever may be that, 0 to t function, 0 to t, n, there are some n graphs are there, that's why. That is equal to n into integral 0 to t f of x dx, that's all. So 0 to nt f of x dx is same as n into 0 to t f of x dx. This is a first formula that we have to remember. The thing is, what you have to remember is, here t should be the period of the function f of x. Then only you have to take n down. You can bring the n down. Then n down means come here as a coefficient. Okay, na? I hope that you understand this property. Such type of some properties are there. Let us see that properties. Welcome back to the remaining properties of the periodic function under definite integration. See here, a to a plus nt f of x dx is same as n times 0 to t f of x dx. See here, a to a plus nt, a to a plus nt f of x dx is same as n times 0 to t f of x dx. Here a is any real number, any real number. For all these three properties we have proofs, but we will take as a granted that we will make use of the result only. Okay, right. Coming to the next property, next property, mt to nt f of x dx. See here, mt to nt, here m and n are integers. M and n are integers. mt to nt f of x dx is same as n minus m, that means here upper minus lower, n minus m 0 to t f of x dx. If it is a t, where always t is the period of this function, always t is the period of this function f of x. Whatever may be this f of x, t is the period of that function. Then 0 to period of the function f of x dx. Understand? Right. So that means upper minus lower n minus m will come. Right. That means the coming to the property number 4, a plus nt to b plus nt, where n is a natural number, t is the f of t is the period of the function, and a and b are any real numbers. Then a plus nt to b plus nt is same as this nt will go a to b f of x dx. Okay na? So these are the 4 properties that we so still some more properties are there. So these are the main properties. Using this we can solve the good number of problems. Okay na? Good number of problems. Okay. For all these proofs are also there. Okay, I am just skipping the proofs. Now I will concentrate more on the problems. Let us see the problems basing on these properties. Okay. Welcome to the first problem here. See the first problem. Integral 0 to 16 pi upon 3 modulus of sin x dx. First thing what you have to know is what is the period of this function. What is the period of this function is pi. Okay na? Modulus of sin x period is pi, whereas sin x period is 2 pi. Modulus of sin x period is pi. Already we explained here. Now here you have to get, so lower limit okay 0. In the upper limit you have to get pi or 2 pi or 3 pi or 4 pi or 5 pi or 6 pi, whatever may be, something n pi. So that we can take n outside, we can make the n down. Then how to do that? Here one fraction is there, 16 pi by 3. So this can be written as 0 to 16 pi by 3. So this can write down 5 pi plus pi by 3 modulus of sin x dx. Can you accept this? Yes, 3 5s are 15, 15 plus 1 16, 16 pi by 3, right. Now coming to the problem, we can, by using the properties of definite integration, so we can divide this interval 0 to 5 pi plus pi by 3 as like this. So this I will separate this interval into like this. Integral 0 to 5 pi modulus of sin x dx plus integral 5 pi to 5 pi by 3 plus pi by 3. 5 pi plus pi by 3. So 0 to 5 pi, 5 pi to 5 pi plus pi by 3. Very clear that I have make use of this of course here modulus of sin x dx. I have make use of the properties of definite integration. That means here this is a property. Integral a to b f of x dx is same as a to c plus c to b. A to c, c to b, right. Now let us see here, 5 is a natural number, modulus of sin x period is 5. Therefore we can take the 5 down. Take the 5 down. 5 into 0 to pi modulus of sin x dx plus. Now coming to here, see here one property is there, a plus nt, upper limit b plus nt, nt, if it is nt, whatever may be that 5t, 60, 70 is there, then this nt will go, a to b will remain. This is one of the properties. Just now we have seen. Here also can I write down it is 0, 5 pi plus 0. See here, a plus nt plus upper limit b plus nt. T is the period of this function. Modulus of sin x function period is 5 only. So this is of the form. See here, a plus nt. See here, b plus nt. Okay. So n is a natural number 5. T pi is the period of that function. Then what will remain? a to b f of x dx. So this is nothing but a to b, that is 0 to pi by 3 modulus of sin x dx. Then almost your problem is completed. So this is equal to 5 times 0 to pi, this is simply sin x dx. Why? Because so here variable, here x is called variable of integration, its interval is 0 to pi, x is 0 to, x belongs to 0 to pi. So 0 to pi means what? It is first and second quadrants. In first and second quadrant sin x is positive, therefore modulus of sin x is sin x. Here also 0 to pi by 3. So x belongs to 0 to pi by 3 means first quadrant. So in first quadrant sin is positive. So this is sin x dx. Understand? So almost the problem is over. Now take the calculation. So 5 into minus cos x upper limit lower limit plus minus cos x upper limit lower limit. Understand? So now get the calculation part. So this is equal to 5 into upper limit cos pi is minus 1, already minus is there, plus minus cos 0 1, that is minus 1, that means plus 1, okay, plus, that is equal to minus cos pi by 3 means cos 60 means 1 by 2, so minus 1 by 2 minus cos 0 1, cos 0 means 1 minus 1, already minus 1 is there, plus 1, okay. So this is equal to 10, so this is equal to 1 by 2. So altogether the answer is 21 upon 2. This will be your final answer. 21 upon 2 will be the final answer. So it is a very nice problem. The first thing is separating like this. Separating like this is important. 16 pi by 3 I separated into 5. So how to get, sir? How to get? First you have to observe the the period of the integrand modulus of sin x. Modulus of sin x integrand is pi. Therefore, you have to write it as a 5 pi, 3 pi, 4 pi, 6 pi, whatever may be that, depending upon this upper limit. Okay, now, right. After that, we make use of this property and this property. The problem will be very easy. Okay. I hope that you understand this solution. Let us go for next problem. Welcome back to this problem. This is evaluate minus pi to 199 pi under square root of 1 minus cos 2x by 2 dx. Then how to do this problem? The first one, observe the integrand. Observe the integrand. So here the integrand is this. This value is, anybody can say, 1 minus cos 2x is equal to under root of 2 sin square x by 2. 2 will cancel. Root of sin square x means mod of sin x. Clear? So whatever may be that, root of 1 minus cos 2x by 2 is modulus of sin x. We know that modulus of sin x periodicity is pi. That means now your problem is integral I minus pi to 199 pi modulus of sin x dx. Okay, now, right. Just now we have seen one property, that is integral mt to nt, where t is the period of the function f of x. T is the period of the function f of x. Then n minus m, upper minus lower, n minus m, integral 0 to t f of x dx. Here also see here m and n are integers here. M and should be integers. Here also see here modulus of sin x period is pi. Modulus of sin x period is pi. Here what is the integer? 199. Here what is the integer? Minus 1. So can I apply that property? Yes, I can apply. So what is that? Upper minus lower. So this is equal to 199 minus of minus 1. This is equal to n minus m integral 0 to pi modulus of sin x dx. That's all. Understand this. So 199 minus of minus 1 plus 1, 199 plus 1, this is equal to 200. So integral 0 to pi sin x dx. As we know that integral 0 to pi sin x dx is equal to y, because in 0 to pi it is a Total first and second quadrant sin x is positive, right. So, this is equal to 200 into minus cos x upper limit lower limit, okay now. So, this is equal to 200 into cos pi is minus 1, already minus 1 is there, plus 1 minus cos 0 is 1 minus 0 plus 1. So, that is equal to 1, total 400. 400 is your final answer. Always remember this value is 2. Integral 0 to pi sin x dx is value is 2. Always remember 0 to pi sin x dx value is 2. Okay now. Why? Because that is also we have one property. So, that is a 0 to pi. The area of this region is 2 units. 0 to pi. The area of that region is 2 units. That also remember in the area of the triangle. Okay, right. So, I hope that you understand this problem. So, we make use of the properties here. Okay, right. So, let us see the next problem. Welcome to this problem. Here one show that type of problem it is there. Show that integral 0 to n pi plus alpha modulus of sin x dx is equal to 2n plus 1 minus cos alpha, where n is a natural number, alpha lies between 0 to pi. Right. Let us see that problem, how to do that. Right. We will prove it using a left hand side is equal to right hand side. What is the your left hand side? Integral 0 to n pi plus alpha modulus of sin x dx. Okay. Modulus of sin x. Modulus of sin x is period is what? Pi. So, here n pi is there. So, n we can take outside. That is why I will divide this interval 0 to n pi plus alpha like this. So, this is 0 to n pi modulus of sin x dx plus integral n pi to n pi plus alpha modulus of sin x dx. I make use of the properties of definite integration. A to b means A to c, c to b, like that I separated. Right. Here already it is given that pi, we know that pi is the period of the function modulus of sin x. We can take the n down. So, this is equal to n into 0 to pi. So, this is 0 to pi modulus of sin x is okay. Next step I will write down, no problem. Right. So, here we have one property. For example, you take it as a n pi is there, no? So, you call it as plus 0. So, we have one property. So, here n pi, a pi, b pi, c pi, whatever may be this n pi will go 0 to alpha. So, we have one property. Just to rewind it. So, this is equal to 0 to alpha modulus of sin x dx. Okay now, right. So, that means so this is some t a plus n pi plus b plus n pi, then n pi will go, this a to b will remain, a to b. Almost the problem is over. So, this is already, so this is a n into, so this is a 0 to pi, this is sin x dx plus 0 to alpha, this is also sin x. Why? Because here it is given that alpha lies between 0 to pi. 0 to pi means what? It is the first quadrant, sorry, first and second quadrants. First and second quadrant sin x is positive, therefore modulus of sin x is sin x. Almost the problem is over. So, this is equal to n into, just now I told its value is 2, 0 to pi sin x, 0 to pi sin x, that hill area is 2 plus. So, this is equal to minus cos x upper limit lower limit. So, this is equal to 2n plus minus, so this is cos x, sorry. So, this is a minus cos alpha, minus of minus plus cos 0 1. So, this is equal to 2n plus 1 minus cos alpha, which is equal to right hand side, 2n plus 1 minus cos alpha. Very nice problem, very easy problem. So, first I separated 0 to n pi plus alpha, 0 to n pi to n pi plus alpha. There also I applied the one of the properties of this definite integration on periodic function. Here also I applied one of the properties. Okay. Afterwards, the problem is very easy. Okay. I hope that you understand this solution. Let us go for next problem. Dear students, welcome to this last and final problem of this today's class. See, by seeing this problem, everybody will get somewhat tension. You are getting tension. So, sir, what are this many problem, this much very big problem? Okay, so don't worry about that. So, use the properties of definite integrations. We will get the. So, first you try to understand what is given, right? F of x be a continuous and periodic function such that f of x is equal to f of x plus t. F of x is equal to f of x plus t. From this definition, what is the period of this function t? What is the period of the function f of x t by definition? Okay, now right, keep it like that. One day, two hints are given. Two hints are given. The first one hint is minus 2 pi to a plus 5t f of x dx is equal to 19. 0 to t f of x dx is equal to 2, then find the value of 0 to a f of x dx. From the very first given data f of x is equal to f of x plus t, the period of this function is t. We have given f of x, period is t, that is the first one. Let us take this data solution. This is a minus 2 pi to a plus 5t f of x dx is equal to 90. Okay, now I will, using the properties of definite integration, I will separate the interval into two subintervals like this. Integral minus 2 pi to minus 2t. So, here it is a 2t. So, this is a minus 2t to 5t f of x dx plus integral 5t to a plus 5t f of x dx is equal to 90. So, this is a minus t to, that means a to c, c to b, minus 2t to 5t f of x dx plus f of pi to a to 5 pi. Okay, now right. So, we have one property here. We have one property. What is that property? Upper is 5, here lower is minus 2. So, we have one thing here, integral some m a n a f of x dx. So, this is equal to, sorry, here n, right, n t. So, this is also n t. So, this is a n minus m 0 to t f of x dx, n minus m. Okay, now. So, here 5 minus of minus 2, 5 minus of minus 2 how much? Plus 2. This is equal to 7 into 0 to t f of x dx plus, see here one more property I am going to use here, plus 0, you call it as 0. Okay, this property is also we have, that is what is the property, a plus some nt, b plus some nt f of x dx is there. So, if it is nt same it is there, then it is a to b f of x dx. Here also see here 5 pi, of course here, sorry, 5t here. So, this is a 5t, minus 2t to 5t, 5t to a plus 5t. Okay, now 5t. So, f of x, the f of x period is t, 5t, we can remove from 0 to a, we can write down. So, this is 0 to a f of x dx is equal to 90. This implies this is equal to 7 into 0 to t f of x dx, it is given 0 to t f of x dx value is equal to how much? 2. 7 into 2 plus integral 0 to a f of x dx is equal to 19. So, integral 0 to a f of x dx is equal to 7 2s are 14. If it goes that side, 19 minus 14, 5. So, your 5a will be your answer. See here, by seeing this such a long and a big problem, the solution is a very simple. So, take the given data. First thing is, by this seeing the definition, you have to confirm that the period of the function is t. Okay. Now, take this interval minus tt to a plus 5t. I separated. Afterwards, I applied the properties of that periodic function under definite function. definite integration, I got the solution as 5. Okay. So, dear students, I hope that you enjoyed today's class with some more problems which were given in a previous JEE mains examination. I will stand before you. Until then, all the best.